the cloud. Now, okay. Let me now start. Let me cancel this one. This is done. And I want to open that folder, which is equal to this. Here. Download. Okay, so here is the document. Remember, you must always remember this definition if someone asks you what is p-value. If someone asks you what is p-value, then you must memorize this definition. P-value is the probability of obtaining results at least as extreme as observed results of a statistical hypothesis test under the assumption that null hypothesis is true. This is the definition of p-value. P-value is the probability of obtaining results at least as extreme as the observed results of a statistical hypothesis test under the assumption that null hypothesis is true. Okay, so in this case, this is the document, and I am going to run all of these things in next 45 minutes by using Python. Okay, first of all, I ran all of these packages. After running this, I read the data. Here is the data that I have read. My data is there. D1 is my data. So from the data, I want to delete all missing values. Okay, and then data has a repeated measurement. I just got rid of the repeated measurement, and then I created a categorical SBP variable and categorical weight variable. So this is the categorical SBP variable, and this is the categorical weight variable has been created. So now if you take a look at the data D3 dot head, you will see this is the data D3 dot head. Okay, this is the data. Clear, right? So in your exam, if I give you a data, you have a data like this. Now after this data, let me run first test of hypothesis. For the variable age SBP, take a look at the board, please. For the variable age SBP and weight of the D3 data, test whether average age is 15 years or not. What does that mean? You are testing here. You are testing here number A. You are testing here age 0, average age equal to 15 or not, an alternative hypothesis or not, like this. This is the one. Okay, so let me do that one quickly. This is what we are doing. Average age 15 or not. I run this. Are you seeing? That is the line number 47. I run. I got these results. Are you seeing p-value is this, right? So when p-value less than 0.5, you will say that null hypothesis of age equal to 15 has been rejected. Clear? Because p-value less than 0.5. In your exam, I will give you data and I will ask you test whether DISP variable is 100 or not. So you will see in the data, you will put data in there, and then you put DSP variable, and then you put there 100, and then you will get the result like this way, and then p-value is this, then you will say p-value equal to that, which is less than 0.5, we reject the null hypothesis. Clear? Okay, so similarly, that is testing whether as average SBP is 100 or not. Line number 49 is testing whether average weight is 65 or not. So the question number 1 is gone. Now question number 2, repeat 1 and 2 with alternative hypothesis is right-sided and left-sided. Python does not have a built-in function for the one-sided test, but the p-value that we will get, we just need to half it, and in that way, or we have to double it from the two-sided test, then it will be our one-sided test statistics. Okay. Now, question number 4, test the equality of the two means. That means for DBP when race equal to 1 and race equal to 2, and then BMI when race equal to 1 and race equal to 2, and total cholesterol when race equal to 1 and race equal to 2. Okay. So that is what we want to do like this. Oh, what happened? No, that is not. So we have to do this one. So let me explain this code to you. The question number 4. If you take a look at the question number 4, from D3 data, I am selecting race equal to 1. So D3 race equal to 1, and then I am putting DBP. Similarly, D3 data, I am taking race equal to 2 with the DBP and then D3 data. So I am checking whether the average DBP for race equal to 1 and race equal to 2 are same or not. This is what I'm testing. Understand? If you have a doubt, read the Word document. Understand? If you have a doubt, read this Word document. Question number 4, this Word document, if you read what the code is doing, if you read this Word document, you will understand. Are you okay? Okay. Very important thing, because in your exam, you will get the data, you just have to run the code. So if you do not read this Word document, do not understand this code, you would not be able to do well in the exam. Clear? Okay. So this is the equality of diastolic blood pressure for race 1 and race 2. P-value equal to 0.99, which is greater than 0.5, we fail to reject the null hypothesis. Similarly, BMI, p-value is very small, so we reject the null hypothesis. Similarly, for the TC, total cholesterol, p-value is greater than 0.5, we fail to reject null hypothesis. Listen, if p-value greater than 0.5, fail to reject null hypothesis. If p-value less than 0.5, reject the null hypothesis. Can you remember these two things? Okay, could you tell what I said? If p-value, tell the way I said. If p-value less than 0.5, reject the null hypothesis. If p-value greater than 0.5, fail to reject the null hypothesis. The girl in the back, could you tell what I said? Do not reject. Yeah. If p-value less than 0.5, reject the null hypothesis. If p-value greater than or greater equal to 0.5, fail to reject null hypothesis. Clear? Okay. Number 4 is done. Now number 5, we want to do test whether proportion of smoker is 0.25 or not. Test whether proportion of smoker is 0.25 or not, which we can do by running this. Okay. So, and then after running this, if you write here P, well, you will get this. So P value is less than 0.5, we reject the null hypothesis. Okay. Okay. So now question number 6 is test the equality of proportion for smoking when race equal to 1 and race equal to 2. Test the equality of proportion. So test the equality of proportion for smoking when race equal to 1 and race equal to 2. Okay. So race equal to 1, what is the proportion of smoker? Race equal to 2, what is the proportion of smoker? That things can be done by using this. And we already did it. And p value equal to this. Okay. Then construct the confidence interval for mean for SBP and TC. So this is the confidence interval for the mean for SBP. And this is the confidence interval for the mean for DBP. Clear? Now question number 8 is telling you confidence interval for the difference of mean SBP when race equal to 1 and race equal to 2. So when race equal to 1 and when race equal to 2, there is a when race equal to 1 and when race equal to 2, there is a difference of mean SBP and DBP, which we can construct in question number 8. And then if you write like this, here is the answer. Okay? Here is the answer. Okay, question number 9. Construct confidence interval for proportion of smoker. Confidence interval for proportion of smoker. Proportion of smoker confidence interval. Here is the way you can construct proportion of confidence interval for the proportion of smoker. CI underscore low and CI underscore half. Sorry, up. I'm saying half. It's up. So this is the confidence interval for the proportion of smoker. Okay. Okay. Test whether proportion of smoker is this. Test the equality of the proportion for smoker. Question number confidence interval for the difference of proportion. Construct confidence interval for difference of proportion for smokers. So this is the confidence interval for the difference of two proportion. This is construct confidence interval. This is construct confidence interval for proportion of a smoker. Construct confidence interval for difference of proportion for a smoker when race equal to 1, race equal to 2. That is the question number 10. Now question number 11 is asking you construct a pairwise t-test for the equality of means of SBP and DBP. Equality of the mean for SBP and DBP. That is the equality of the mean for the SBP and DBP. Remember, last two classes, I discussed lot of test of hypothesis, confidence interval, right? This Python code is giving you how to conduct test of hypothesis when a data set is given or variables are given. Clear? To become expert on this code is very important. Otherwise, you would not be able to do the final exam. Clear? Are you okay? Yes.
So is this like the type of code you do to see how the job, or
Yeah.
do they have like a different system?
No, Python is same. Python code, their script, their syntax is same. Okay. Yes. 10 question. One question I told you, right? From where? Optimization, right? Optimization, one question, and graph paper, right? Right? And then 2-3 test of hypothesis question, maybe one confidence interval question, 5 question is gone. And remaining 5 question is coming from correlation and regression. Maybe altogether one optimization question, 5 or 6. Okay, one optimization, 5 questions is coming from test of hypothesis, 1 from confidence interval. So 6 and 7, and 3 from correlation and regression. Okay, clear, right? 3 from correlation regression, 5 from test of hypothesis, 8, 1 from optimization, 1 from confidence interval. One problem you are getting from confidence interval, 1 from optimization, and confidence interval, optimization, and 5 from test of hypothesis, 7, 5 from test of hypothesis, 1 from confidence interval, 1 from optimization, and 3 from correlation and regression. Okay. But correlation, regression, test of hypothesis, confidence interval, all of this, if you use this Python, it will be easier. Okay. So be an expert. Try to run these things again and again, and read the Word document. Try to understand. Read the Word document. What you will do? Read this Word document. Are you seeing that Word document? Are you seeing that Word document? And run that corresponding code so that you will become expert. When you read the questions, then you will match. Well, which question is matching? Okay, this question. So question number 9 code is in there. Okay, let me copy that code. Okay, after copying that code, change the data and change the name of the data and change the name of the variable. That's it. Okay. Okay. Now question number 12. Test whether variance of DBP is 60 or not. Test whether variance of DBP is 60 or not. So this is a specific variance test. And then you can write here p-value. You will get this p-value less than. Question number 13 is asking you also test equality of variance for SBP and DBP. Equality of variance. Equality of variance. This is the equality of variance. Okay. So if you have a problem of understanding these things, this means this 1, 2, 3, this means this. This is the F statistics. This is a single tail p-value. This is a double tail p-value. Okay. Also test equality of variance for the variable SBP and DBP. Also test equality of variance for the variables SBP and DBP. So question number 14 is asking you test equality of variance for SBP for two levels of raised variable. Question 14. Two levels of raised variable. Here is the answer. Okay. Question 15 is asking you test whether median SBP is 100 or not. In my test of hypothesis problem, I did not discuss how to conduct the equality of median test. Median of a data set is 70. That is called the Wilcoxon test. I did not discuss that, but here in the R code, I provided that, which is equal to this. Okay. And then question number 16 is a test equality of median SBP corresponding to raised variable. Corresponding to raised variable. Which is P value. Okay. That is the test equality of median. That is the question 16. Test whether median SBP and median DBP are equal or not. Question 17. Mean SBP and mean DBP are same or not. So if you write here P underscore value 1, you will get 17 P value 1, the 1 I wrote, there is error here. Test whether independence of like categorical weight variable and categorical systolic blood pressure variable. You remember, we did the independence of two categorical variable, opinion as well as affiliation, right? Opinion as well as affiliations. Now, if I want to do same thing for the categorical weight and categorical SBP variable, how can we do that? That could be done by using this. This is the question number. This is statistics P value two-tailed. This is the expected. So this is the P value. From there, you can say that P value less than 0.5, we reject the null hypothesis. Okay. Question number 18 is asking you test independence of SBP. So whatever paper and pencil approach I have discussed for teaching you test of hypothesis, all of those Python code are in there. I am afraid that you might do bad in the final exam. Previous exams you are doing very well. If you do not become expert on this part only, then you will have a trouble, because I will give you data which may be empty cars, which may be iris data. Okay. And then I ask you, so this iris data as that variable, check whether mean of that variable equal to this. So in such a case, you just need to, that is why become a super expert on this. Read this Word document multiple times. Okay, read this Word document multiple times. Test whether mean SBP are same for different levels of this. This is the ANOVA test, which I did not discuss theoretically, but later maybe you might need it. Okay. After that, test whether mean SBP are same for different levels of that. Test whether SBP is normally distributed or not. Run this test against log scale SBP, test whether SBP correlated or not. So now this is called the normality test. This is called the normality test. Like whether SBP is normal or not. What I am doing in here, D3.SBP, I take the log and NP.log. It is in the log scale. I am now testing Shapiro test, whether the log of SBP is normal or not. I got the p value equal to this, which is bigger than 0.5. So we fail to reject the null hypothesis. Okay, we fail to reject the null hypothesis. Okay. Shapiro test. Now, different levels of this normally distributed. Now I want to test this one. You remember correlation test? I did the right correlation test. SBP and DBP are correlated or not. So how can I do that? This is the correlation test. 21. 21. Test whether SBP and DBP are correlated or not. So I run this SBP and DBP and take a look at the p value. So p value equal to that. Okay. And what was the null hypothesis? They are not correlated. Correlation equal to 0. So correlation can be -1 to +1. So I was testing whether correlation equal to 0. That null hypothesis is rejected because p value is less than 0.5, right? Understand? Remember, in your exam, I will give you data. On that data, I can ask you, check whether mean of this variable is equal to the mean of that variable. Okay? I can ask you, check whether this and that variable are correlated or not. Second question is God. I can ask you, check whether proportion of this variable is equal to the proportion of that variable. Right? I can ask you, check whether the mean of this variable is exactly equal to that or not. I can ask you, check whether variance of this variable is exactly equal to this or not. Here, right? Okay, after that, correlation part is done. Run test, we have to conduct a run test. Run test, we have to. Okay. Now correlation and regression. So D3 is the original data. Let me run the D3 again. Correlation and regression. Control P. I just need to get rid of that. Okay. I just got rid of that. That is done. Here is I'm checking correlation of SBP and DBP variable. So if I want to put here 0 and 1, So then I will get just the correlation of D3 data, where from the D3 data I am taking SBP variable of race 1, EBP variable of race 1. So I am finding their correlation between 0 and 1, which is equal to this. But if I do not specify 0 and 1, then see what is coming. It is giving a correlation matrix. It is giving correlation matrix, okay? So the line number 272 and 273 has a difference of correlation, specific correlation and correlation matrix. Okay, Pearson method. Okay. Correlation can be done by Pearson method. Correlation can be done by the Spearman's method. Correlation can be done by Kendall-Tau method. So this is what all I discussed in there. Okay. Now come to the, this is the correlation matrix now. This is the correlation matrix. Has been constructed. I want to construct now regression thing. So without, so this is the, are you seeing in this case, this is the regression of weight. This is the coefficient, regression coefficient beta 1. In this case, I did not use intercept. So that is why I wrote there without intercept. Above this, there is, I wrote there regression without intercept on the line 343. Okay. And then line 347, I write regression with intercept. So in your exam question, so if you run the line number 348 to 351, you will get this output. From there, you have to report my intercept is this, which is equal to constant. This is your intercept, and that is your beta 1. Okay. These are the two things I might ask you in the exam to report this from your regression output. So what you will have to run? You have to run line number 348 to 351. Okay. In order to report that too. And then if I ask you, find whether your slope and intercept are significant or not, you will take a look at the p-value, and p-value is less than 0.5. You said that yes, null hypothesis of zero coefficient and zero slope is rejected because p-value equal to that. That's the way you have to explain. Okay. Are you okay understanding? Okay. So many of you, actually many of you did very well for throughout the semesters. I am happy by teaching this course, and you continuously came and asked me question. The office hour you showed up, and but try to know that it is said in our country, in the context of our society, those people whose ends is good, everything is good for them. Do you know what I said? At the end, what you did good, so everybody will say you that you are good. You understand, right? So last few years in your life, if you are a very good persons, benevolent person, kind persons, give lot of charity, and then you die, then people will say you are a good person. Or you maybe they will say they will forget their previous one. So similarly, in the final, if you did well, so that means you will get. So there are a lot of materials actually for the final exam, right? So test of hypothesis, correlation, regression, confidence interval, and optimizations. How many fingers? Optimizations, confidence interval, test of hypothesis, correlation, regression. Okay, so this is what we have. Then there is a multiple regression things is coming in there again. So confidence interval and all of this predicted value, you will see very good prediction in there. Plots. Are you seeing this plot? So this is my all data. Okay, this is my all data dots, and this is the fitted regression line in this one. This is for the confidence interval, this is for the prediction interval. Prediction interval for the new data, so that is why prediction interval is bigger. Okay. So now come to the one that I want to now see. Instead of only one variable, if you take multiple variable, I am taking here multiple variable, line number 392. Simple regression, multiple regression. Okay, multiple regression. Are you saying fit a multiple regression model where SBB is a dependent variable and high and TZ and HDL are predicted variables? Three variables I have considered here. How can you do that? Question number 24. Question number 24, you have to run the problem number this 15. Okay, this 15 if you run, that will be the multiple regression model. And then multiple regression model. So remember line number 390 to 395. Okay. And then if you run this, then I will ask you report your constant value. Okay. Then you will say my constant is 129. Is the constant significant? You said that when p value less than 0.5. So yes, constant is significant. We fail to reject the null hypothesis. What is your A's coefficient? You will say A's coefficient is 0.1324. Is it significant? You said no, because p value is greater than 0.5. Okay. Understanding? So take a look at the empty cards data. Empty cards data from Google. This is known as the empty cards data. That data I will give you for your exam, okay? Empty cards. Empty cards. Empty cards. C-A-R-S. Empty cards. Yes, go ahead. Question.
Is it going to be multiple choice again? Or-
Yeah, multiple choice, or maybe, yeah, multiple choice. Okay? Multiple choice, but you have to do it, then you have to select one, okay? Those people who didn't email me for getting your some points back, okay?
So you said, for the seeds,
What?
you said you forgot everything.
Syllabus, yeah. Next class, I will come, have an office hour in here. If you want to come, have a question, I will be more than happy. If none of you want to come, just email me. Then in that case, I will maintain office hours from my home. Understand, right? So, okay, let me, are you coming next week or not? Are you coming? Yes?
Not sure, I'm not sure.
You're not sure yet. You are player, you are 50% chance not coming, right? You representing our WIU. Okay,
I'm not sure.
okay. So if you could not, I can come. I do not have a problem, okay? I do not have a problem. Yes.
So, when you were us to do the-
Exam, check whether your exam is graded correctly or not. Okay, and then email me. Well,
Okay, so-
Yeah.
okay.
I can see which ones are there, like, I can see. what that's-
Yeah, I publish those things, right?
But I still can't say.
Why? Assessment quizzes. This is the exam 3 grade, and select everything, right? Okay, I'm going to stop in here. Stop recording.